Okay, let's get started. We're going to give you a little exposure with the law of cosines today. And just a little recap here. There are two different laws of sines and law of cosines. And in particular, there's only two situations when we use the law of cosines. That's when we're given all three sides. Those are the examples we're going to do in a moment here. And the other situation is when we're given side, angle, side. And the angle A has to be included. Like I said, we're going to focus on side, side, side here. And there is a little disclaimer. We must always find the largest angle first. Beyond the scope of this class, there are some reasons for that when dealing with sine, cosine, and tangent inverse. There's some potential problems or loopholes. And to get around that, we're always just going to find the largest angle first, and then we won't run into any problems. So let's review what the formula is for the law of cosines, and here they are right there. Here are the law of cosines, and it looks like three different formulas, but it's actually the same formula. And I also want to show you some alternative formulas, the ones that we're going to be using. And it's really the same three formulas as these three, but notice we have just rearranged and isolated. Cosine A by itself would look like this. Cosine B by itself would look like this. And cosine C by itself would look like this. And again, this could be very intimidating if you've never experienced this before. But if you actually write all three of these down, you're going to begin to see a pattern with the letters. So in particular, I like to use this alternative formula when we're given all three sides. I like to use this formula right here, the regular cosine formula, when we're given side, angle, side. And so let's get started with an example. So I'm going to scroll down here, and here we go. Here is the given information. And notice, like in the previous videos, we have to be very sensitive to which one is capital letters versus small case letters. And we're given all small case letters. Those are all the sides. So I'm going to start to draw a picture here. And I don't focus on my pictures being drawn to scale. So my vertices are the capital A, B, and C. And little a is going to turn out to be 12. Little b, which is always opposite big B, which is going to be 20. And little c, which is always opposite big C, which is 18. So in order to use one of the alternative formulas here, okay, which one do we use? Well, a moment ago I said we are going to find the largest angle first. Now you got to think back a couple of chapters in here of how do we know which one's the largest angle, which one's the medium angle, and which one's the smallest in here. Well, there was a theorem called 5, 9, 5, 10. Largest angle produces the largest side. Medium angle produces the medium side, and vice versa. If I have the small side, I'll have the smallest angle. If I have the smallest angle, it's going to produce the smallest side. When I say produce, I'm always looking across the angles to the opposite side. So in this case, we are, to avoid our loophole, we are going to find capital B. Well, if you notice, of these three formulas, this is the only one that has a capital B in it. And that's why capital B is kind of isolated here. So that's the formula we're going to use. Well, at this point, it's really straightforward. We're going to go cosine of B, and now I have to just fill in the values of little a, little b, and little c in here. So little a was 12, so that's 12 squared. Little c was 18, so that's 18 squared, minus little b squared, all divided by 2 times 12 times 18. And that's going to give us a value. And that value actually equals cosine of B. It doesn't equal B. And so remember, at the very end, we have to use cosine inverse, and that's going to give us the angle B. So right now, I got my calculator in my hand. I'm going to go 12 squared plus 18 squared minus 20 squared divided by 2 divided by 12 divided by 18. And I'm getting a value right now of like 0.1574, but that's not the answer. That's the answer to cosine of B. Well, I don't want the cosine of B. I want angle B. So that's where I do cosine inverse of that value, which I'm about to do right now on my calculator. And when I do that, I get an angle of 80.9435 degrees. So I'm going to label that right here, 80.9435 degrees. So when we're given all three sides, it's impossible to use the law of cosines. We have to use the law of cosines. And I use the alternative formula since that is already isolating cosine of b for me. Now, at this stage, I stop using the law of cosines to find the two other angles in here, because now I know everything about a particular letter. And through some experience, you'll realize that the laws of sines are much easier to deal with. So at this point, I'm going to use the law of sines, which says the sine of 80.9435 all over the side opposite, which is 20, is equal to what? The sine of A all over little a, or the sine of C all over little c. Well, let me find A first. So that's going to be the sine of A all over 12. Now, when I start using my calculator, understand I'm trying to find an angle. So I am going to cross multiply, but at the very end, in order to find this angle, I have to use sine inverse. So when I use my calculator right now, I'm going to go sine of 80.9435-ish times 12 divided by 20, and that gives me a value of 0.5925. I'm going to go sine inverse, not cosine inverse, sine inverse, and that tells me angle A. Angle A turns out to be 36.3360 degrees. Now, I can do the same thing for the law of sines again, but now, since I know 2 out of the 3 angles, it's a lot faster to use the angle sum theorem. So I'm going to add up angle B with angle A, and then I'm going to subtract that answer from 180, and that's going to be angle C. So I'm doing that on my calculator right now. I'm taking 36.3360 plus 80.9435, and I subtract it from 180, and then we have an answer for angle C. Angle C turns out to be 62.7204. All right, that's your first exposure to the law of cosines, which could be very intimidating. Let's do one more example here. And trying to find trying to solve for the triangle. So let me move some stuff around here. So when we look at this problem, once again, we're given all three sides. I like to draw the picture. I don't focus on drawing at the scale. And notice I have A, B, and C. Well, little a is going to be 8. That's the one opposite capital A. Little b is going to be 14, and little c is going to be 19. So in this situation, I always want to find the largest angle first to avoid some problems with inverse sine, cosine, and tangent. So in this case, the largest angle is the one we need to find first to avoid that loophole. So I want to find I want to find capital C, and this is the formula I use, since this is the only one with a capital C in it. This one has a capital A, capital B. Well, this is the only one that's going to focus on C. So I'm going to use that formula, which says cosine of C, I don't know capital C, is equal to A squared plus B squared minus 19 squared all over 2 times 8 times 14. And now I got to use my calculator. And just remember, at the very end with the calculator, you got to use cosine inverse. Now don't do that in the beginning, do it at the end. So I'm going to take 8 squared plus 14 squared minus 19 squared, and then I divide it by 2, I divide it by 8, and divide it by 14. Now, this is not a mistake. The cosine of C is actually a negative number in this case. Again, it's beyond the scope of this class. That's basically telling me it's an obtuse angle. But you don't even have to know that. You just have to now, at this point, use cosine inverse to find angle C. And when I do cosine inverse of that particular negative value, I get an angle of 116 degrees, 0.8009. Now, notice that's obtuse. And don't get caught up in that, but this negative value is going to be producing obtuse angles for me. So that is 116.0 8009. So moving on, how do I find the other two missing angles? Well, I can't use the angle sum theorem. I only have one angle in here. I am actually going to stop using the law of cosines and use the very easy law of sines, since now I know everything about capital C and little c. So I'm going to go sine of c all over little c is equal to, I can either at this point, it doesn't matter, find a or b. So I'm going to do sine of a all over little a. So we know these three values right there. The one that we don't know is capital A. So let me just plug in some numbers in here. Sine of 116.8009 divided by little c, which is 19, is equal to sine of capital A, I don't know capital A, all over little a, which is 8. So now when I cross multiply, I'm going to get a value here for sine of A, and then since this is an angle, I have to use sine inverse, not cosine inverse, sine inverse at the very end. So now I get my calculator out. I'm going to go sine of that angle, 116-ish, times 8, divided by 19. And I get a value of 0.3758. I go sine inverse of that particular value, and I get angle A turns out to be 22.0751 degrees. Now I know 2 out of the 3 angles, 22.0751. And if I know 2 angles in here, I'm going to add those together and subtract from 180. Let me do that right now. I added those together. I subtract from 180 on my calculator, and I'm getting 41.1238 degrees. All right, I'm not going to do a full example to conclude here, but I am going to point out that all of our formulas right now have been featuring only 3 letters, capital A, capital B, and capital C. Well, what if they give us a situation where they tell us 3 different letters? Well, if you write down this formula a few times, you're going to notice a pattern. The pattern is, it's the cosine of any angle, and you take the other 2 variables, in this case D and E, they go in this position, and then the side opposite the letter that you're looking for goes in this position, and then these 2 other variables, small case d and small case e, those are the ones that go down in here. So if you analyze all 3 of these top equations, they all really follow the same formula. So if I used x, y, and z, for example, if I did the cosine of x, that would be equal to y squared plus z squared minus x squared all over 2 times y times z. So please be on the lookout if we start changing the letters on you. Don't freak out. Just try to understand the pattern of the law of cosines. Hopefully this is helpful, and I'll see you soon.